Okay, sir. Good afternoon. Today I'm going to talk about my lab assignment one. I'm going to discuss on my lab assignment one because previously I've already submitted my lab assignment one, and I got to know that I need to redo it because of some mistakes that I've made in the first lab assignment. The first submission. So now I'm going to do the second submission, which is like basically the correction of the assignment one. Yes, okay, I'm going to start with the assignment one coding. So actually, I've already done the coding actually, so I have to redo it. I'm not going to do from scratch because I think everything is there. So I'm just going to display, I'm going to keep codes in for each segment. So I'm going to keep the codes and then I'm going to run it and I'm going to see what's the input. The output. I think I've already because the first one is copy folder and rename file. Basically, I've already done that. So copy and rename the file as assignment one. I'm done that. The second one is now is I have to comment irrelevant codes where the 4 lines of pauses. So basically, I've already done the three lines, and now I'm going to do the last one. So I'm done with that. So now I've already done all the pauses, and now I've already I'm going to comment now. I'm going to comment from the beginning because I'm going to run from each segment so that I can understand better. So I should comment here, and there's another comment down here. It is under N. Yes, here. So I'm going to comment here also. Okay, I've already commented here. Previously I get to know that there is some errors because when I type it, the thing comes 2 times and so on. So maybe I'm going to do it from the beginning. So I think I've already done the first. The next I already bring up my project 2 feature extraction. So that one has already came in here. I already put it inside here instead of candy production. So if you see all the one below here is already gray in color, means it's already in the comment. So now I'm going to read the input, which is the third one. I'm going to read the input. So keep the codes only for reading and display input image. So basically I'm going to read for reading and also input image. Basically I'm going to show the image here. So I'm done with that. Modify the code and copy paste image file name. So actually I already done with the copy paste of the image file name. So now I'm going to run and visualize the results for verification purpose. So I'm going to do that. So before that, I'm going to save this file and I'm going to run this. Okay, so if you see, I already run this and I got to see the image as this. This is the image. Okay, so if you see, this is my image here. So I think I've already done successfully the reading input part. So I already done the reading input. Now I'm going to go for the color segmentation where the segmentation part, which is 5%. So basically I need to keep only codes until segmentation. So I'm going to control X here and I'm going to bring it to color segmentation where it's until here. If you see the segmentation part is until here and then there's a pause, so it should be here lah. I put it here. So one you see at the one at the below is all gray in color. The rest so until segmentation the code is still in color. So I'm done with I already keep the codes until segmentation. Now I'm going to run the codes for reading and crop sample of background. So basically I cannot crop this because I have no idea why. So I'm not able to crop. I'm not able to crop, but I can visualize the results. So basically the second part I cannot do because I cannot crop this, but I can visualize. So let me do the visualization. Okay. So if you see my visualization is this, so I already got my image here. If you see there is a few dots here and you see the pictures is the circles and the squares are not really square, not really rectangle. Sorry, it's not square, it's rectangle, and it's not circle. It's not, it is a circle, but if you see the outline there, it's not so clean. So I'm going to do I'm going to do morphological operation to make it clear. So I'm going to cut, okay, I'm going to cut this, Control X, and I'm going to bring until morphological operation, which is until here. So if you see each pause here means that is the ending part for each step. So I'm done with the part. Okay, I already done with this. So now I'm going to do the morphological operation part. Okay, if you see there's the morphological operation here. which I have to create a restructuring element. Basically, I cannot do that. Maybe I have no idea because I'm using an Octave online, so I'm not able to do that. So, but I can still run and visualize the verification. If you see there's a slight difference, if you see here the original image, there is two dots, but if you see the real, the one that after morphological, there is a bit difference where you can see there's no dots, and then a bit okay compared to the before one. I mean, I can say 2-3%, it is okay, but seriously, no, it's still not working. So this part, yes, okay, I'm done with the morphological operation. So I've already doing the visualization, the results. Okay, the next part is very important because this is what I have to redo actually, which is on extract features. It's 20%, it's quite a lot. And I have to do that again. Control X. Okay, the future extraction part is over here. So if you see here, I'm going to do it again because I'm going to do on my, because before this was area. So I think now in this part here, we are going to do on thinness ratio. So thinness ratio stands for TR. So I'm going to put TR here. If you see here, I'm going to explain one by one. 4 times pi is here is like the, if you see the formula for thinness ratio, it's over here. I'm going to open the formula for thinness ratio. Okay, it's in my notes. If you see here, thinness ratio is supposingly should be in second part of feature extraction and analysis. I'm going to open this. I'm going to show you that I'm going to show you the proof that where do I get the formula from, because thinness ratio, I mean, I've done that in my test before this. So so thinness ratio, we're going to use thinness ratio now. Let us see what is the formula. So basically I know the formula, but to be safe and to be, I mean, to be right enough, we will see what is the formula is all about. Okay, we wait for the word to open. So it takes some time because my laptop is very slow. So it takes some time to open the word. Okay, I hope it will open now. Okay, it's already open. So now we're going to talk about binary object features. One of the features here we're going to use here is on thinness ratio. So if you can say thinness roundness ratio, let me see the formula. The formula is somewhere here only. Okay. Okay, if you see the formula is here, so I can make it enlarged. Let me do it. I mean, let me do it this. Let me do it an enlargement. So I don't know whether you can see. Maybe you can go through here. I'm going to make it okay. So I think it's clear enough. If you see here, thinness ratio is actually identified at 4 pi area over P is for perimeter basically. So A is for area, P is for perimeter. Perimeter you need to square it, and 4 pi times area over perimeter squared. So here, if you see, you want to know this thinness ratio as the, I mean, if you want to know whether this thinness, what is the meaning of thinness ratio here? Why do we use thinness ratio? So if you see perimeter is required to calculate the useful feature of thinness ratio, this feature is very useful in describing the shape roundness of an object. So basically, if you see, if the because since we are using circle and we are using rectangle, so circle is more to round and rectangle is more to flat. So we are using thinness ratio to identify whether it is a circle, it's a round shape, or it's a rectangle shape. So I mean, basically, thinness ratio is used to find whether normally they used to find the shape of an object. So that's what it's here. And if you see the ratio part, how do you say if it's how do you tell that it's how do you know that it's whether it's round or rectangle? As the object becomes thinner and thinner, the perimeter becomes larger relative to the area, and the ratio decreases. So basically, as the object gets thinner and thinner, the perimeter becomes larger, and which relative to the area, and the ratio will be decreasing. So as far as we know, it, that this ratio becomes 1 when the object is circled, the nearer to this ratio to 1, the more like a circle. So basically when the more it is to 1, the more that we can say that the object is actually a circle. And the more the thinner the object is, the perimeter becomes larger and the ratio becomes smaller. So basically it's a rectangle. So this is what we're going to talk about. So I'm going to go to the octave again. Okay, so if you see here, that is what I'm using 4 times pi in a bracket. Because why I put pi bracket, because I can say here, if you enter here, so if you see the value 3.1416, if it's so that is the value for pi. So because yeah, that's the value for pi. We have been learning from if I'm not mistaken, we're learning from form 3. So this is the value for pi. So 3.142, because they round up it as 2 here because of 6. So it's the same thing with this. So that's why we're using the symbol as pi in a bracket. Dot, okay, always we put dot is just because each time when we have something there, when we have a value, so we have to put a dot. So times binary features, because we call here binary features, which is area, perimeter, and also image. So now we are using more on area and perimeter because we want to. This is basically to find the thinness ratios formula. So we're just actually putting in the form. We are putting in the values into the formula. So that is where binary features one where I1 is the total object basically. So total object times the area divide by, so divide in a bracket, definitely should be in a bracket, because if you see the formula, it is also it is in a bracket. And moreover, why I put a bracket down there for p, which is for perimeter, is because to make sure that because perimeter has to be power 2. So if you see here, binary features one, I mean the total of binary features for the total object, dot perimeter is a value, and dot you need to power 2. So basically power 2 is because we are squaring it. So that is why we're saying that it's power 2. So we are done with the formula part, but then we cannot do that because we have to bring the okay. So if you see the down everything is gray. So now we have already done until the extract feature. So I already keep the codes. Like what I have to do is only keep the codes until the function region props. So basically this is the function for region props. So binary features. Now, in order for me to do that, I need to find the value for area, perimeter, and also for the object tr. So I'm going to do a run. So to make sure that whether it's really working or not, so I'm going to use Excel. So what I'm going to do is basically I'm going to save this and I'm going to run this. Okay, if you see, I've already run this. So our total object here is actually 8. We have 8 objects. Why I'm saying 8 is because if you see here, okay, let me do this. Okay, if you see here, why we're having 8, because we see there's 4 rectangles and as well as 4 circles here, round shaped. So I'm going to close this. So that is what 8 objects. So now 8 times 1 is object tr. So this is the value, but we can't be just using this. I mean, we cannot use the value from here. But before that, because the value is already given, so to make sure that it's really true, or it's to make it how to say, to verify check variable if desired features are available, whether um, it's really working or not. So it is in the compute features, because I already done the region props part where I already made it to area, perimeter, because we need to add in perimeter here, because thinness ratio we need area and perimeter to do it. So and the image as well. So that's why region props I have to include perimeter. So I'm done with the extra features part. Now I have to compute like what I'm saying I have to do in Excel. So I cannot open the bind features here. So maybe what I can do is I can just do it here where I'm going to put bind features, so that I'm going to see what are the values given to me, what are the things that are given to me. Okay, I'm going to enter. Okay, if you see here, it is area, perimeter, and image. Why I'm saying area, perimeter, and image? Because you see binary features here, has given some in a region prop has given area, perimeter, and image. That is why I can see area, perimeter, and image here. So from there, total number of objects equals to binary binary feature. Bin features is actually binary features. And next, I'm going to do to find each value for area, perimeter, and also for image. So bind features, where I have to put dot here because a binary features is 1 and area is 1. So I'm going to put enter. Why I'm using here binary features dot area? Because we're using here the same thing, binary features dot area. So these are the values given by my program here. So my pictures here is giving this. This is my area for each, because there is 8. So means my first circle it should be 10920, and then my second circle, my third circle, my fourth circle, my rectangle, my another rectangle, another rectangle, and the last rectangle. So there are 8 objects. So each object has a different area. So that is why the values are all different. So I'm going to actually copy this thing and bring it to my Excel. Control C. So I already opened my Excel here. So I'm just going. It's a new page. So I'm not going to do anything here. I'm not. I mean, I didn't do anything here. So I'm just going to put it into the first one. First section here. I'm going to start with area. Area. So the second part here, I'm going to just because I've already copy paste, right? So I already Control V, right? So I'm going. I mean Control C, right? So I'm just going to drag this thing. Should be until 9, and then I'm going to Control V. Okay, if you see, I've already controlled everything, and then just that we need to remove this answer part. We don't need answers all here. We just need the values only. So because the only thing, because in Octave it's giving answers, so when I copy, it will definitely will come until answer. I cannot copy only the values. Okay, so I'm going to it takes some time to actually delete all this answer part. Okay. Okay, another one. Okay, so I'm done with the area part. So let us check whether it's right or wrong. So if you see here, maybe I could just make it this way. Okay, if you see here, 10920 287 4394 977 5354 283 2380 513 931. So basically, we are done with this. Okay. So now let us go for perimeter, because for Retinos ratio we need to use area and perimeter. So we're going to use, since area and perimeter, so we're going to take this. So I'm going to type it again because now I'm going to use perimeter. So we have to come up with the same thing, binary features dot perimeter. Okay, if you see enter, I'm going to enter this. If I enter, I got my perimeters already. So the same thing, I got my area and my perimeter. So perimeter is basically the perimeter for my all the 8 objects, 4 circles and 4 rectangles. So I think it's very clear there. Control C, and I'm going to bring it here. So I'm going to drag until 9, and I'm going to Control V. So if you see again, I got the answer part. So I'm going to just delete all these things. So there's no way that I am going to do my working through with answers here. So I don't want the word answer and the equal sign. So I want only the values. Okay, I'm done. Okay, I'm doing it. Okay, and then answer. Okay, so I've already done until the answer part. So now let us do the formula. So which I'm going to start with TR. So TR Excel. Excel. Okay, so TR Excel here, I'm going to start with my, so I think I should make it a bit bigger, so that because maybe the values will come a kind of a big value. So I'm going to just make it this thing so big. Okay. So now for Excel part, what are we going to do? We're going to put the formula into it. So now the formula here is actually equals. So equals basically the sum. Okay, as we know, the formula here is actually for, again, pi I mean for you have the times, right? So times pi. Okay, see pi is already given here, so you can just take the pi over here. So see, it's automatically you have the open and close bracket. So definitely you need to put a bracket because it's a function. It's already given to us. So 4 pi, and then of course area for area. So area. So now we're going to do for the first one. So area, it will be A2. So if you see, this is A, this is 2, so it will be here this value. So A2, and then so you see all the A2 is already highlighted as blue, and then you have to divide B. I mean, you have to put it in a bracket where B2. So B2, can you see the B2? So B2, where you have to times with another B2, because you cannot make it power here. So there's no you can't, I mean, you can't do power here. Okay, wait, B2. Okay, so closing bracket. So I'm already done with the formula. This is the formula: 4 times pi times a square divided by b square a square plus a2, which is area, or divided by perimeter times perimeter. So to make it perimeter square. Okay, done with that. So I'm going to press enter. So I got the value ready. So I'm going to bring up all the values here. So basically I got all the values ready. So these are my values for each and every object. So basically for my first circle, this is my, so this is basically Excel. So I use calculation through Excel, manual kind of calculation, Excel calculation. So now I'm going to use the calculation as given to me in my MATLAB. Okay, I'm going to use, since I'm using Octave, so I'm going to use Octave. So to make it somehow I know what I'm doing actually. So to make it since I did in Octave, so I'm going to do it in Octave. So yes, we are going here. So if you see here, if you see the area part, so I have to make it big. If you see here, I already have my object. But the problem, I already have my total object, and I already have my object TR, but it's in this form, so it's not easy for me to copy paste. So what I can do is, since the object TR is the value, so we just have to make OBJ. Sorry, it's capital OBJ. You have to follow exactly so that it will. Okay, enter. So I got my values for OBJ. So this is the values given to me basically after my. Why I'm saying it's OBJ, because you see OBJ TR is the values that I got from the calculation. So basically this is the value given to me through Octave. Control C, and then I'm going to copy paste here. Control V. So I got my values ready. So if you see, you want to make it, if you see it's right, it's right or wrong, I think it's almost right. So 099,844,064,453. So it's the same thing as this. So I think it's right. So now what we're going to do is to make it the difference. We're going to check the difference. Either it is really it's really working or not working. So what are we going to do is we're going to do the difference, diff. So for difference, what are we going to do is we're going to put equals here, C2. Okay, basically we're going to take the Excel one that we got and we're going to minus with the Octave one. Minus, okay, we're going to see whether it's really working or not. Minus the D2. Yeah, D2. So it should be D2. Okay, and then you press enter, and then I'm going to drag the whole thing here. So I got my values already. If you see my values here, everything is like 10 to the power of -5, 10 to the power of, so there's so very slight difference, and you can see there's so many negatives here. So I can say that it's, so we're going to omit that. So it's still, I think it's still working. So this is what the value that I got. So I think it's right. It's okay. It's fine. So what are we going to do now is, okay, so this is what my result is basically, sir. So okay, I'll give you, I just see, go through that. Um, I think it's fine. Negative 5, 10 to the power of e is there, is exponential. So 10 to the power of negative 5, 10 to the power of, so it's all very kind of very small values given to me. So, okay. So for octave part, I already find the working. So now I'm going to use, I'm going to see the last part, which is to classify the features. So basically, I'm done with what I'm supposed to do, the computation, and also to extract the features. So yes, I already keep the codes until the loop. So this is the loop. Basically, I'm done with that, and then I already checked the variables. So now I'm going to actually run the entire file. To run the entire file, I'm going to delete this, Control X, which I don't need that anymore because we are already coming to this last part, which is to classify. So basically, this is the average. You're going to put the average into this to find. So object TR, it should be more than average TR. So to make it round shape, right? So that's not, as I mentioned to you inside here. The more the object is more, the more the object is thinner, the perimeter becomes larger and the ratio decreases. So something like that. So when the average becomes decreased, then the real object, the object TR, so therefore it's a round shape of, or else it will be a rectangle shape. So I'm going to take out this pause also, because to make sure that I can run each time, because I'm not going to do like, I'm not going to make it like it's going to run like all the time, to make it one by one so that you know how it really works. So yes, of course, I'm going to save this and I'm going to run this. Okay, so if I run this, then I got my, so I got my the first circle. So I can just press enter because they say press enter to continue. So this is my second circle. So I think I don't know how to make this big. Big. Maybe I'll show you later how it actually making how it's all the circles and the rectangles look like. So I'm just going to press enter. I'm going to finish up this thing first. So there's another circle. It's another circle. So the last circle, and next I'm going to move to rectangle, rectangle, another rectangle, and another rectangle. So okay. So basically, I all have the average. So my average here is 0.80143. Okay. So now I'm going to see the circle. So to make it clear for your visualization. So this is my last rectangle just now. The previous one, so there's one rectangle here, another rectangle here, another rectangle. So basically, all you can see all the title is the same. Rectangle means rectangle, and round means round. So altogether there are 4 rounds. So that's it. So far, I'm done with the assignment 1 part. So I think for, I can seriously can see that this time the assignment 1 is way better than the before one, because before one is very clumsy and I don't know what I was doing. It's not that what I don't know what I was doing. Actually, I know what I'm doing, but just that it was very because it was late night, and then there's so many people here, so I'm not able to, because I'm in a room now, so I'm not able to actually do it. I've skipped this looping part. So I think shouldn't do that. So this time I think I made it the right one. So I did that. I think I almost done from scratch actually. So I thought I've already told you each and every time what it happens. So thank you so much, sir. So I'm done with my lab assignment 1. And yeah, see again, connection lost and attempting to reconnect. Okay. So yeah, that's it, sir. Thank you so much for listening to my lab assignment 1. Thank you.